Hello everyone, welcome to this presentation. I am Anis Moabedin, PhD student in Filippo, and I'm going to talk about comparison between rigid and ductile adhesives in CFRP steel joints. As you may already know that there is a wide application of FRP in concrete structures. It is commonly applied for any type of structural elements such as beams, columns, slabs, piers, etc. However, when it comes to steel structures, although some successful case studies that I'm showing here, there are very limited applications in field. Here I'm showing you some bridges that were retrofitted with carbon fibers. Here you can see two very old bridges that were made of iron, a very brittle material, and Acton Bridge in London that was repaired because of fatigue problems, and Hanshin Bridge in Japan for seismic actions. And the reason for the delay, or at least the main reason in my opinion for the delay of the application of CFRP in steel compared to concrete structures is mainly due to the failure mode. In concrete structures, the weakest part, usually it is the concrete substrate. And engineers and researchers with civil engineering background, they have a lot of knowledge about this mode of failure and could easily derive design procedures. However, in steel structures, usually it's the adhesive connection that is the weakest part. And researchers with civil engineering background usually do not have a lot of experience in adhesive technology. And another important reason that is very related to this presentation is that most previous studies on steel CFRP joints used linear brittle adhesives made specifically for concrete, as you can see here in this figure where the adhesive has the same color of concrete, it's gray, and it is mainly made for concrete structures. It may provide some satisfactory results, but not enough to boost this technology in the steel construction industry. Here I'm showing you what we are doing in Filippo. We launched a large experimental campaign where we are trying to characterize the tensile fatigue behavior of different adhesives, fracture mechanics parameters of different adhesives and joints, and testing static and fatigue tests of CFRP steel bonded joints, and also some structural elements reinforced with CFRP. Here I'm showing some puddle iron that was extracted from Lewis Bridge that has more than 100 years old, and we are testing them under static and fatigue load. And the focus of this presentation is mainly on double strap joints that are shown here in this figure with ductile and brittle adhesives. It is mainly made of two steel bars with gap in the middle. The bars has 10 millimeter thickness and patched with carbon fibers. Now, all the specimens were prepared equally, and all the steel bars were sandblasted with a very specific sand that is recommended for this application. The CFRP were polished with sandpaper. All the specimens were made in aluminum mold that you can see here that has some pins in order to make sure that the CFRP and the steel are aligned, are well aligned, and we use some spacers, aluminum spacers, in order to maintain the thickness of the adhesive when we close the mold. So now let's talk about the adhesive that we use. Here I'm showing you the ductile adhesive that we use, which is Araldite AW4858, and two brittle adhesives, which are Sicadur 30 and SPHP 220. You can see that the ductile adhesive can achieve high strength and very large deformations without losing significant strength, while the others achieve high strength but very low deformations. Well, for testing, we tested all the specimens in MTS machine under tensile static loading with speed 1 millimeter per minute, and we used DIC camera to measure the deformation in the CFRP. Now let's see some results. Here I'm showing the results of the specimens made with the brittle adhesive Cicadur 30. As you can see here that the joints achieved a strength between 65 and 85 kilonewton, which is around 50% of the yielding of the bar. And you can see here the failure mode, which is mainly cohesive failure with the CFRP delamination at the ends where there is large peeling stress. Now here I'm going to show you a video of the DIC results on one face of the CFRP. Note this is half of the specimen, and here is the gap, and this is the CFRP plate. Let's see. You can see here that there is concentration of deformation in the gap in the beginning, and then the deformations start to move while the debonding is moving up until the complete failure. Here you can see that with the DIC we could at least capture the propagation of debonding. Now let's see the results of specimens with SP adhesive, which is a brittle adhesive too. Here the adhesive has a higher toughness than the previous one, Cicadur 30. And as you can see that it achieved higher force, which is between 100 and 120. And the failure mode was mainly CFRP delamination because it has a higher toughness than the CFRP. And the maximum force is around 75% of the yielding. Now let's see the results of specimens with ductile adhesive. Here you can see that the specimens with ductile adhesive achieved very high strength, which is 160 kilonewton. Note that the yielding force of the steel bars here is around 150 kilonewtons. And what is very interesting here, what we noticed is that first the yielding occur of the steel, then we have the failure of the joint. These are very promising results, especially from the design perspective, because one can use the steel yielding criterion as the criterion for failure of the joint, which is much more easy than any other existing methods. Now here in this figure we are comparing the typical three joints with the three adhesives. As you can see that the ductile adhesive reaches much strength than the two other brittle adhesives, and the SP adhesive achieved higher strength than Cicadur 30, and brittle adhesives provide more stiffness to the joint. So in general we can say that ductile adhesives have much higher performance than brittle adhesives, as you can see. However, in construction industry, large amount of adhesive and CFRP are required, and we usually use very thick adhesive layer. And the economical aspect really matters. As you can see here, in the brittle adhesive cost around 70 euros for 6 kilograms. However, the ductile adhesive is much more expensive. For half kilo is 100 euros, which is 11 times more expensive. And this is a very important aspect that we need to consider. And in here we are trying to provide a solution that take the advantages of the ductile adhesive while reducing the cost. And this can be done by using the bi-adhesive technology, which which consists of using brittle adhesive in the middle, mainly brittle adhesive everywhere, and ductile adhesive in stress concentration regions, in the edges and in the middle. And and here in this figure, where I'm showing you the results, where you can see here, this is the brittle adhesive in red, and in blue it's the ductile adhesive. In gray there are different specimen configuration that depends on the length of the ductile adhesive. What you can see here, the specimen with 10 millimeters of length of ductile adhesive achieved very high performance, which is very promising because this solution is providing very high strength and a balanced stiffness, and it is cost effective. This is the end of my presentation. This research is part of Fiber Bridge research project that is funded by FCT. And here you can see our supporters, industrial supporters. Thank you for your attention.